Okay, this is the recording for section 8.3, the notes for intermediate algebra. And in this section, we're going to learn how to multiply polynomials. Now, if you recall from last time when we were adding polynomials, you had to have these exponents right here be the same. They were called like terms. That's not true for multiplication. So we're going to look at here maybe the meaning of these exponents. When you've got that x to the second power, it means x times x, and the other one, x to the third power, that means x times another x. So because it's multiplication all the way down, including that center multiplication, you can consolidate it and call it x to the fifth. Well, nobody wants to have to write that all out every time, so the shortcut here is that when you're multiplying with the same base, you add your exponents up, so that second power and third power become fifth power. On the next example, example B, we're introducing these front numbers called coefficients. We're multiplying the 3 and the 2, but we're also multiplying the x to the third and the other x to the third. So we're going to start out with the answer, and then it's color-coded here. I'm going to show you how I got each part of this answer. You multiply, you add the exponents like the last problem, and you multiply the coefficients. So that 3 times 2 that's in pink there, that's where I got the 6, but the exponents get added up, 3 plus 3, to give a sixth power. That's the green one. Okay, moving on to example C. Your coefficient numbers are not as obvious on this one. The -2 is not a problem, but that negative sign that's in front of the x is like having a -1 there. So we're going to multiply the pink numbers and add the exponents on the others, even though it takes a little bit of thinking. This is like having a first power on each of those. But when you multiply x times x, you get x squared. So if you just study how I put that together there, the -2 times the -1 is where I got the 2, and x times x is x squared. Okay, on example D, we're going to end up having to distribute up here. So I'm going to do that first here. Well, that's all we need to do on this problem. So once you realize that you have to distribute, multiply across the parenthesis. The first one here would be 2 times that 3, and that would give that 6x. And then the other part of the distributing would be the 2 times the -5, and that's where -10 comes from. Okay, those are some pretty easy problems. You're also going to have to multiply longer polynomials times each other. And essentially, it's just the distributive property used multiple times on the same problem. Now, if you have a binomial times a binomial, you use a version of it that's very familiar. You multiply first, outer, inner, and last. This is often called the FOIL technique. But really what it is the distributive property in action. So if we move down here to example A, actually we won't get to that FOIL technique until we get to example C. The first two here involve distributing. So first you distribute in that blue section there, -3x squared times 6, and that's where that -18x squared comes from. And I've color-coded the red part too, so you can see where I got that. And you may notice that this is not in the right form. You've got your x cubed at the back. When it's the highest exponent, it belongs at the front. So I've rearranged it, and that would be putting it in standard form. That's kind of a funny S, but anyway, standard form is what that's supposed to say there. Okay, on the other side, example B, it's also a distributive property application, and you can see I've got it color-coded here, the blue part first, the red part second, and the green part last. And just to highlight part of it, when you take that 2x squared times a 6, you end up with this negative 12x cubed. Just see if you can convince yourself that it should be x cubed. There's an x squared on the outside times one more x would make 3 of them, and that's why it's x cubed. Not to mention that you just add the exponents. Okay, the first problem that actually uses the FOIL technique is example C. You can see that it's a binomial times a binomial. That's when you use FOIL. So I've got this all color-coded here. In black is the first part times the first part, and that gives 10x squared. The outside pair gives 2x. The inside pair gives 15x, and last times last would be 3 times positive 1, and that's just 3. Now, typically, the outside and the inside, they're usually the ones that this happens to. They combine because they're like terms, so the 2x and the 15x becomes 17x. So you've got some addition stuff going on in the middle of this multiplication problem. Okay, example D is a little bit dangerous because people misapply the distributive property to exponents. This is not the answer. The person that thinks this is the answer squared the 6x, and that is indeed 36x squared. And they took negative 7 times negative 7 and got 49. But exponents don't distribute. You'll see in the end that this is part of the right answer, but it leaves out a crucial step. The correct way to interpret this is to think of the squaring as multiplying by itself. So you can see I wrote the 6x minus 7 times itself, and then you have to FOIL that out. So let me show you where the color coding comes in. The first one here times the first one over there, we're going to call that first times first, and that's where the 36x squared comes from. Then you have the outside pair, that one and that one, and they give negative 42x. We next move to the inside pair, which also gives negative 42x. And then finally, we have the last one, negative 7, times the other last one, negative 7, and that's where the positive 49 comes in. Now, when you combine your like terms on this, the minus 42x and minus 42x gives minus 84x. And if you compare that with this one up here, you can see that it's missing part of the correct answer. So exponents right here, they don't distribute. Very common mistake, by the way. I think it's one of the more common mistakes made in high school mathematics. All right, this is not a binomial times a binomial. You won't be using FOIL on this, but you'll use something that looks quite similar to it. So let me unbury the first part of this answer here for us. 8x cubed plus 20x squared minus 12x is how we get this ball rolling, and I'll show you where that comes from. You distribute the first part, there's your negative 8x cubed, and you take that 4x times the next one, and finally you take 4x times that last one, and that takes care of the 4x being distributed. But then you need to distribute the other part of it. And I'll show you where these come from. That's the latter part, the 1 times that one, and that one. Now, if you look carefully, you might notice that I took my like terms, let me show them to you, my x squareds, my x's, and I lined them up over each other. So it makes the next step really easy. You just add your like terms, and in this case, the middle one's all 20 minus 2 is 18, negative 12 plus 5 is negative 7. Okay, example F is the same type of problem, except that it starts out backwards. So the first order here is to get that thing turned around. Then you multiply the 3x times all of the terms in the other side. So 3x times that one, and times that one. And that's what I've got there. You can, for instance, see the 3x times that negative 2 would give that part. And then you turn your attention to the next part of that binomial, the negative 4, and multiply it times all the other terms. I'll show you where that comes into play. There's my negative 4x, there's my minus 20x, and there's my plus 8. And as I write it down, I think about which terms are similar, or like in this case, and I've got my x squareds lined up and my x's lined up. So when you combine those like terms, you don't have to look around for them. They're sitting right above each other, and you got your final answer there. Okay, so we've got 2 more to do, and they both involved a third power on a binomial. So there's really a similarity in these problems. Once you get the first one done, you might even be able to do the second one without my help. But when you cube something, you multiply it by itself, and by itself. Now, once you've got x minus 2 times itself, then you concentrate on the back half of it, and you look at the x minus 2 and the other x minus 2 that I've highlighted in light green here. You FOIL those out. Let me label everything here. First times first is right here. Outside's right there. Inside's right there. And last times last gives that 4 at the end. All right, I'm going to consolidate the like terms inside those parentheses. You can see I put the negative 2x and the negative 2x together. And now we're back on familiar territory. You're going to be distributing the x first and the negative 2 second. Let me color code this so you know where I got everything. First, you take the x times all 3 of those. And then you take the negative 2 times all 3 of those. And I've got it already color-coded. You can see that I lined up my like terms. And the final answer here is when you collect those like terms, you end up with this long expression. Okay, example H is actually the same type of problem. So I'm going to go through it rather quickly. Write it out as 2x plus 3 times 2x plus 3 times 2x plus 3. FOIL the back half. Collect those 6 x's and put them together. And then you distribute the 2x across and the 3 across. You haven't done very many of these, so I'm going to show you where I get each of them. There's my 8x cubed, my plus 24x squared, and there's my 18x. And then I simply do the same thing with the 3. There's my 12x squared plus 36x plus 27. All that remains is to collect the like terms here, and we're going to be done. So that is it. That is how you multiply polynomials together. Okay? So that should do it for you, and hopefully you'll be able to complete that 8.3 homework. And get ready for the test that covers this section.